I, Dr. Amit Kishor, working as an associate professor in Department of Computer Science and Engineering. I am here to teach you the subject Automata. This is flat, known as flat. So the target is the study the formal languages and automata theory. This subject in the fourth semester of the Computer Science Department in the Swami Vivekananda Savarkar University. So now start the subject. Before going to the in-depth knowledge of this, so I want to give you some introduction about some definitions, some basic concepts of some particular basic definitions. Like first one is automata. The term automata is derived from the Greek word. This is known as autoera, which means the self-acting. Automata are abstract models of machines that performs computation of an input by moving through a series of states. This is the in automata theory. What we are doing here, we are planning to execute from the one state to another state to the next state. This is the outgoing process from one state to second one to third state until unless we are not reaching to the final state. This is the model. What we say. Next term definition is symbol. These are mostly used in the automata. This is symbol. Symbol. Symbol is single element from an alphabet. Like suppose we are giving like sigma is a symbol. Delta is a symbol. So these are the symbols representation of these symbols we are using in the automata theory. Next is alphabet. Alphabet. Everybody knows about the alphabet. This is we have in the English characters we have 26 small letters. This is alphabet. But here an alphabet is finite set of symbols. Alphabet is a finite set of symbols. Example like here in the first example, A comma B. B an alphabet. Here is the A is alphabet, B is alphabet. In 1, 2, 3. B an alphabet, this 1 is alphabet, 2 is alphabet, 3 is alphabet. Like the last, I have written A, B, C till Z. So B an alphabet set of lowercase letters, isn't it? Now, the next topic, word is a string. A string is a finite sequence of symbols. This is started with the symbols of an alphabet. This is the sequence of alphabets, not single alphabet. There is a number of alphabets, maybe 1, maybe 2, maybe 3, maybe 4, and maybe any number of alphabets we can use in the strings. For an example, I have taken some example to make it clear. First, like A comma B, be an alphabet. Then, suppose we have considered two alphabets only, A and B. So we have considered only two alphabets, A comma B. How many strings we can design using this two alphabets? Like double A comma B, AB, double B A, AB are example of strings over sigma. These are particular 4 strings I have designed here, but we can generate number of strings can be generated. There is number of strings like double A, double B, triple A, triple B, AB, series of AB. We can generate the very number of strings we can generate. This counting, we cannot do the counting. This is infinite. Like sigma is equal to, suppose the alphabet is 1, 2, 3. Be an alphabet. Then triple 1, like 1, 1, the combination of 1, 1, 2, 3, 2, 3, 2, 3, 2, 1, 3 are the examples of string over sigma. Or many more examples we can give or can give I am able to explain. So this is the alphabetic numerical. This is basically the numerals 1, 2, 3. Now come to the next. This is language. What is the language? We started from the alphabet, symbols, strings, language. This is the chain language. It is a collection of strings. Examples. What is this? This is the collection of a string. Collection of alphabets is known as strings. Collection of a string is known as language. So L is a language. L is the representation for the language. Any language is represented in the automata is by the capital L. We can represent. So the set of all strings over 0, 1, then that end with 1. We have to find the number of sets that is started with any one, no issue, but ending with 1. And we have to start it from the 0, 1. Matlab, we can start by the either by the 0 or by the 1, but the ending with 1 only, is it? Now, suppose this is the answer of this language generated, like 1 is a language, 0, 1, 0, 1, 1, 1, 1, 1, 1, dot, dot, dot. This is can be an infinite. The language can be generated infinite only by these two strings. The next is the most important part of the automata is clean star and clean closure. What is the meaning of clean star? Clean star and clean closure both are the same. We are representing the same. Sometimes we are seeing that somewhere is written like clean star, somewhere is written like clean closure, but both are the same. Now, the clean star, due to this star on the sigma, it is known as the clean star. A star is there in the clean star is a unary operator on a set of symbols of strings over sigma. This is generated by the unary operator. This is unary operator. In the other words, sigma star is the language consisting of all possible concatenations of the strings from L, including the empty string. Means empty string is a part of this clean star or clean closure. The string contains the empty. The language contains the empty string also. Example: the clean closure of a language L is also denoted by L star. Thus, any language we suppose we have generated the language L, and for the L we are trying to generate the clean closure or clean star of that language. At that particular time, we have to use the word like L to the power star. It is also defined as the clean star of a language L 0, 1 over the alphabet 0, 1 is what will be happening here. L star. This is the formula for the L star. This is L. This is L0 union. This is L0 union L1 union L2, and it goes to number of times. That is infinite. L2, L3, L4, L5, L6, L7 is a continuous process. So we have considered till like L2 for this example we have considered till L2, and we have represented the other by the dotted points. L0 means the string which contains empty string. This is sigma. This is epsilon, not sigma. This is epsilon. This is union L1. L1 means 0, 1. This is generated which having the string having the length size is equal to 1. Here the length size is equal to 0. Here in case of L1 the length size is equal to 1. In case of L2 the length size of the string is 0, 2. So this is 0, 1, 0, 0, 1, 0, and 1, 1. So combining all together, this is sigma starting with the epsilon 0, 1, 0, 1, 0, 0, 1, 0, 1, 1. This is representing the null string, 0 length string. This is 1 length string of the length size 1, 1. This is 2 length size, 2, 2, size is 2. And when the executed text, this will come 3, 4, 5, infinite number of series we can observe. And this is what? This is a set of all strings over sigma. It means if we are writing these symbols only, this is a set of all strings over sigma, it representing this one. Isn't it? Next example for the clarification, we have considered some more example also. Like if L is equal to A. Suppose we are giving only the word alphabet, a single alphabet A is given. Now we want to generate the L star. So how we can generate? The string size with the length 0 size, the string size with the 1. So now this is epsilon, single A, double A, triple A, because this is coming why A? Because we have considered only single A. That's why we have taken number of A as a part of the L star. Suppose I have considered L is equal to AB. So we have considered two words. AB means what? AB, 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 AB. This is AB, AB is not a two word. It's a single word concatenated. If there is two words, there is a comma. A comma B. But there is a no comma. So it will be considered as a single. This is AB. This is AB, 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 AB. So we cannot take A, we cannot take it simple B, because two word is coming continuous. Now the next is clean plus. Clean plus. This is the next version of this clean star. This is clean plus. This is represented by the plus sign. On as earlier we have represented with the star sign for the clean star. Now this is a clean plus. That's why we are representing it by the plus sign to the sigma. Or we can also represent the plus sign with the L. It is defined as, how we are defining it? This is defining as L plus rather than L star. This is L plus. L plus is started with there is some S. This is L1, L2, L3, L4, L5. Okay, here is the L1 is there. So in other words, L plus is the language consisting all possible concatenation of one or more strings over L. Isn't it? And the difference is what? What is the difference between L star and L plus? The L star is considering the word empty string, but the L plus is not considering the empty string. We are not considering. Suppose example, like L is equal to A. We are considering it from the A, double A, triple A. In the previously, we have taken L is A. It started with the sigma, epsilon. But here we have started with the A. If L is equal to AB, then we have started with the AB, 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 AB. Or there we have started with the epsilon. This is the main difference. If L is equal to 0, 1, then L plus is equal to 0, 1, 0, 1, 0, 0, 0, 1. 1 0 1 1 triple 0 and many more examples of this clean plus. Now coming to the next topic of this this is formal language. What is the meaning of this formal language? Just come here. A formal language. A formal language is a set of strings of symbols from a finite alphabet. This number of alphabet is a finite, defined by a set of rules or operations. Formal languages are used to describe the syntax of programming languages, data formats and other structured data. Means what? We are just going to design the formal languages, and that formal languages containing the main highlighted part is this is a finite alphabet. We are considering the number of alphabet is a finite. We are not taking the infinite alphabets. There is a set of rules or operations. The formal languages are used to describe the syntax of the programming languages. Formal languages is used to describe the syntax, what kind of syntax we are providing to the system, to the computer, is generated by the formal languages. Format of the data, what kind of format we have used, and the other structured data, what kind of data structure we have used, is known as this is formal language. Basic concepts, again, this formal language component. These are the components of formal languages. The first component is the alphabet, sigma, a finite set of symbols. Second is the strings, finite sequence of symbols from sigma. Language, capital L, a set of strings. So there is a relation like alphabet with a finite set of symbols, strings, finite set of symbols from sigma, language, set of strings. Just one are coming one after one. This is formal language operations. What operations we are using here? The first operation is like a union. we can consider two union operation between the two languages, L1 and L2. Concatenation, this is a dot operation, this is L1 dot L2. Clean star, this is, we have studied 2 minutes back, this is L star, this is clean plus, L plus. Now, the automata theory is almost over, basic definitions is almost over. Now we are considering the types of automata. The first one is deterministic automata. In deterministic automata, what is happening here? This is deterministic. So you can take the name deterministic. The name is determined. Deterministic automata is a type of finite state machines that accept or reject input strings based on a set of rules. These machines accept the strings or reject the strings. Either this is based on the rules of the machine. It is called the deterministic because given a state, and input symbols, the next state is uniquely determined. So we can determine the next state also. So we have the input symbols. So now come to this definition, 5-tuple definition. This is DA is defined. DA is a deterministic automata. Is defined as a 5-tuple. This is Q is a finite set of states. A state, number of state. In this is we have considered like 5 state. We have considered Q, and Q is representing the state. So suppose we have 5 states. How can we represent? This is represented by Q1, Q2, Q3, Q4, Q5. Or we can start by the any state we can consider like X, Y, Z, 5, any 5, or Q0, Q1, Q2, Q5, whatever you suit, you it, you can take it. So now this is sigma, a finite alphabet import symbol. This is the input symbol. The third one is the transition function. This is the main important function. This is the transition function where input and alphabets combine together, and this is giving a transition function, generating the transition function to Q, and the Q is also the set of this states. Now Q0. The next term is Q0. Q0 is the initial state. F is a set of final state. Initial state is there. Q we are representing initially this Q0. F is a set of final state. This is represented by Q. The next is the transition function. Delta takes a state and an input symbols and returns the next state. The DA starts in the initial state Q0. Always it is starting with Q0 and reads the input string symbol by symbol. This one by one is reading the strings. Transitions to the next state based on delta. The movement of the transitions is based on the delta function, whatever delta we are using. If the final state in F, the input string is accepted. Suppose after the execution of the whole system, whole transition, we started with the input initial state and reaching to the final state, then the machine accepts the string. If after execution of the transitions, we are not reaching to the final state in a DA, then this machine is not accepting the string. So there is two states, accepted or rejected. Once this is accepted, means we are on the right platform. If it's rejected, it means this is not right platform to accept the machine. Now, I have taken some example also for this. This is not the example. This is the transition function and transition diagram, transition table and transition diagram. So, what is the meaning of this transitions? I am going to tell you the weightage of transitions. Here a table is given. Here a table is given. So, first I will see the table. That's why we can consider. Table contains 3 states. This is 3 rows, columns. This is current state, and the last is next state, represented by Q and Q dash. This is input symbol. Input symbol in program in the language it is given. The state is either we have to design or we have to already given the state. Suppose here there is 2 states, Q1 and Q2. and the input is 0 and 1. This two input. So what is happening here? At the Q1 we are getting the 0 as an input and reaching to a state Q2. Q1 at the input G1 maintaining the same state, not going to the next state. At the state Q2 we are getting the symbol 0 as an input, so going to the Q1 state, and at the state Q2 getting the input 1, reaching to the next same state is the Q2. Is it? Now every transition values and functions are defined. So now come to the definition part. A transition table is a tabular representation of a transition system in automata theory. It is concise way of describe the transition between the states based on the input symbol. This transition is based on the input symbol. There is a transition from one state to another state. And this is the table representation. This is the table typically has the following columns. This is the current state, input symbol, and the next state. Now, if we want to represent this transition table into transition diagram, then just this table into diagram. So currently, what is the point to be noted? This is Q1 and Q2 is the two state. Input, we have the two inputs only 0 and 1. Now, I made it. This is two state Q1 and Q2. This two state is there, and at state Q1, getting the 0 as input, reaching to Q2. Q1 to Q2. This is going to Q1 is going to Q2 when the input is 0. See, Q1 is going to Q2 when the input is 0. Q1 is maintaining its state to Q1 when the input is 1. See, Q1 is maintaining its state when 1, this is at Q1. And what about the Q2 at 0? This is going to Q1. Q2 at 0, this is 0 is missing, 0 is going to Q1. Now Q2 is at Q2 at 1. Input at 1 is putting at the value 2. This is the transition diagram of the same. So one more thing I want to tell you, that this is suppose in the deterministic automata or any automata, we need the two state at least. The one is the initial state and the second one is the final state. So whenever we are writing any state, we are saying this is the initial state, so we are giving this arrow sign to the same state. This is arrow as input, like suppose this is the Q1 is the initial state, so arrow sign must be given here. Now this arrow is indicating means Q0 is the initial state, and the double circle is indicating that Q1 is a final state. Other state is a simple state. So in this example, we have taken, just showing this example, this is three states, Q1, Q0, Q1 and Q2. In these three states, two states. This one, Q0 is the initial state, Q1 is the final state. Initial state is denoted by the simple arrow, and the final state is denoted by the double circle. Now, come to this point, deterministic finite automata. DFA refers to the determined finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata. If the machine is read an input string one symbol at a time. In DFA, there is only one path for a specific input from the current state to the next state. DFA does not accept the null move. The DFA cannot change the state without any input character. Means what? So this is showing this is uniqueness. One state is defined, that other state it will go to the next state, and this is the only one path. What is the meaning of one path? See, at Q1 is equal to 0, Q1 at getting the 0 is going to the only at Q2, not going to anywhere other than Q2. At Q1, getting 1 is coming to the back on the Q1, not getting to the Q2. Matlab multiple, it means multiple path is not available for the same input. So come to some example like DFA. This is I have taken this some example. Like in the following diagram, we can see that from the state Q0. Already we have 3 states. Q0 for input there is only one path which is going to Q1. Q2 to Q1 is going by A. Q0 there is only one path for the input B going to the Q2. This is showing this one path is given only. The other path is not given. Come to the question. Some examples is here. In this example, so we have taken 3 states. This is 5 tuples definition. The transition diagram is given here. This is first is the state. We have 3 states: Q0, Q1, Q2, and input state is 0, 1. Q0 is the initial state. This is Q0. F is the final state. Q2 means this Q0 is the initial state and Q2 is the final state. Q1 is the middle state. This is the diagram. This is given, and this is either we have the transition diagram or transition table in the defect. So we have the diagram is given. So we have to what we have to do? Transition diagram is shown in the above figure. Make the transition table. We have to make the table. So how we can make the table? So first I will consider for the making the transition table. We will consider the 3 columns. First is the input state. Second is the input value, and the third is the final state. See, present state, input and input state at 1. So we have considered like input at 0, input at 1. Q0 at input 0, we have taken 0. Same. Q0 at 1 reaching to 1. Q0 at 1 reaching to 1. Q0 at 1 or 0. At 1 it is same at 1. Sorry. At 1 it is a self loop, and at 0 is going to the Q2. Q1 at the 0 it is going to Q2, and the 1 is at the same loop. Now come to Q3. This is Q2. Both case at 0 and 1, this is coming to the as a self loop. Q2, this is Q2, Q2. And in the table, we are also representing the initial state and final state. The initial state is represented by, as told you, that is arrow, and the final state can be represented by the star or a double circle. Now, example 2. We are considering the example 2 of the DFA. Suppose example 2. Design a DFA with sigma is equal to 0, 1 except all ending with 0. All strings is to whichever ending with the 0. Now I have made the diagram first. How this is executing? This is like we have considered only 2 state. Q0 state and a Q1 state. At Q1, this is 1 here is the initial state. Q2 is the Q1 is the final state. Now getting 0. So what is the problem? Problem is ending with 0. The string can accept like 0 0 1 0 double 1 0 1 triple double 0 at the ending with 0, not ending with 1. So whenever we are getting 0, going to the final state, going to the final state, going to the final state. Whenever we are getting 1 before 0, this is coming to the same loop. This is coming looping on this same Q0. Suppose we are getting the 1 after 0. This is 0 1. So this string cannot be accepted. So at that time it will start from the Q0, it get the 0 and reach to the Q1. Then 1 he did 1, he come 1 input again is coming. Then after getting the 1, this is coming back to the Q0 and wait for the next input. But we don't have a string, so the string will be rejected. But in case of suppose we have considered 1 double 0, what will happen? At 1 we have just looped here at same state. This is 0 and this is 0. Come to the second part of this is non-deterministic finite automaton. as the topic is concerned, this is non-deterministic. Before this, this was deterministic. Now this is non-deterministic. Non-word is added here. So non-deterministic stands for the NFA stands for the non-deterministic finite automata. It is easy to construct an NFA than DFA. It is easy to construct than DFA. Means it is so simple to calculate the NFA or design the NFA rather than to design a DFA for a given regular language. Now, non-deterministic finite automata, it is a type of finite state machine that recognize patterns in strings. Unlike DFA, deterministic finite automata, NFA allows multiple transitions on the same input symbols from a single state. Means, what is the basic? This is multiple transition is allowed from the same input to the next state. It is also defined in the 5 tuples. This is Q1. Q is the same as the finite DFA. This is finite state. Finite set of states. This is sigma is the finite alphabet input symbols. This is transition function. This is delta is defined here. This power is 2 to the power q. Q0 is the initial state. F is the final state. The properties, all the properties are the same as the like the DFA. So now next. The difference. What is the difference? Why? What is the difference between the DFA and NFA? The key difference between the DFA and NFA are the multiple transitions. NFA allows multiple transitions on the same input symbols from a single state. Means at the same input symbols from a single state. Multiple transitions are allowed. Now non-deterministic is a non-deterministic meaning that the next stage is not uniquely determined by the current state and input symbols. Because this is multiple transitions are allowed, that's why we cannot predict where the next state will come. Suppose at the Q0, there is 2 states. Suppose there is 2 states Q0, Q1, sorry 3 states Q0, Q1 and Q2. And we are going to at 0, we are going to also on the Q1 from Q0 to Q1, also from Q0 to Q2. So how can we predict that where we will go? This depends upon the string. This is epsilon transition. NFA allows a epsilon transition without consuming the input symbols. Without consuming the input symbols, we can move to the next step. This is the property of this NFA. Now, come to the examples. There is an example. Here, 3 state is given, Q0, Q1, Q2, where Q0 is the initial state, Q2 is the final state, and the Q1 is the middle state, or you can say the mediator state. 2 inputs is there. This is set of inputs is Q0, not 0 and 1. Initial state is Q0 represented by the arrow sign. Final state is Q2 represented by the double circle. So a state transition diagram is given. Make transition table. So we have to make the table. So how? It's easy to make this table. So we have taken present state, input state, and input at 1. Next state for input 0, next state for input 1. Now first we write the state Q0, Q1, Q2, 3 states here. Q0 at 0. Q0 at 0. How this is Q0 and Q1 is coming? This Q0 at 0. Come. Q0 at 0. At 0, this is coming back, and at 0 again, this is 0, this is going to the Q1. So Q0 and Q1 both are coming here, Q0 and Q1. Now, Q0 at 1, it is going to Q1. Q0 at 1, it is going to the Q1. This is Q0 at 1 going to the Q1. Now coming to the, now we are at the Q1 state. This is. At Q1, we are getting the 0 as input, going to the Q2 state, getting the 1 as input, going to the Q0 state. This is Q1, at 0 going to the Q2. As per the diagram, this is getting the 1 input, going to the Q0 state. Again, this is Q2. Q2. 0, 1, it's again looping it here. And Q2, this is going to the 1, Q1 also, getting the 1 as input. Means at 1, we can maintain the same state or go to the Q1, previous state Q1. This is Q2. At 1, maintain the same state, Q2. And going to the back on the Q1 state. At Q2, this is 0 and we are maintaining the same state because 0, 1 is maintaining the same state and 1 is going back to the Q1 state. So the things are written here. We can see that when the current state is Q0 on the input 0, the next state will be Q0 or Q1, that's Q0 and Q1 on 1 input. The next state will be the Q1, this is Q1. When the current state is Q1 on the input 0, the next state will be Q2, this is Q2. And 1 input, the next step will be Q0, this is Q2. When the current state is Q2, this is current state is Q2, okay. At 0, input, they are going to the state Q2. On the state 1, at the input 1. Next state will be the Q0, Q1 and Q1. This is the example. I can explain more. This is one more thing is that this initial state is represented by the dash, this arrow sign, and the final state is represented by the stars. Now, come to the next example. This is the example. Determine an NFA that accepting all strings over 0, 1 which ends in 1 but does not contain the substring 0, 0. It means the input is 0, 1 meets all strings which ending with 1 but does not contain 0, 0 as a substring. Means what? So what is the condition here? The string should end in a 1, single 1. This is single 1 here. The string should not contain 0, 0. The substring, the part of the substring inside the string cannot be a 0, 0. This is the basically diagram I made, and you can make the transition table with the diagram of the diagram. I have considered 3 states. See, I have considered 3 states: Q0, Q1, Q2. I made Q0 as the initial state, Q2 as the final state, and Q1 as the intermediate state. So what is happening here? So we are getting, suppose ending with 1 does not containing 1, 0, 0. Means suppose we are getting the string like 0, 1, 0, 1. 0, 1, 0, 1. Fourth size of the string is 4. This is 0, 1, 0 and 1. This is accepted. Suppose lower length string is simple 1. So Q0 2, 1. Suppose the string size is 2, 0, 1. Now 0 and this is 1. Suppose we are getting 1, 0, 0, that could not be accepted. So what will happen? 1. Then suppose we are coming from this way, 1 and 0. Then there is no way to go. When we stop the machine, the machine will be rejected. So this is the main basic concept of the NFA. So we can continue with the next lecture with the various topics.